Your field support team at Northline Industrial gets the same warranty questions every week. The answers live in internal PDFs and safety bulletins that legal will not allow on a public chatbot. Cloud ChatGPT is off the table. Contracts and incident reports cannot leave your network. In this lesson, you will build a private GPT local documents, a local model, and LangChain to connect them. A private GPT means your data never crosses the internet to a vendor API. The model runs on your machine or your company's server. You control what it reads. For compliance teams, that is the difference between approved tooling and a policy violation. You are not training a new model from scratch. You are grounding answers in your own files. Ollama is a local model server. It downloads open weights once, then serves them on localhost. Think of it like running your own mini chat GPT on the company network. You pull a model with one command, then Python talks to it over HTTP on your machine. Common starter models include Llama 3.2 for chat and Nomic embed text for embeddings. Open the Ollama site to confirm the install steps for Windows or Linux. LangChain is not the model. It is the wiring layer between your code, your documents, and the LLM. It gives you document loaders, text splitters, vector stores, and chain objects you compose in Python. Instead of hand rolling every step, you connect small pieces into a retrieval pipeline. The official docs on python.langchain.com show the same pattern we will build today. For a support desk bot, the pattern you want is RAG Retrieval Augmented Generation. First, load your internal files into LangChain document objects. Next, split long pages into smaller chunks the model can search. Then, turn each chunk into a vector embedding with a local embedding model. Store those vectors in a database on disk. Chroma is a good default. When a user asks a question, retrieve the closest chunks. Finally, pass those chunks to the LM so the answer stays grounded in your policy text. Here is the LangChain introduction page. Notice how they describe chains and components. Document loaders read files. Text splitters break them up. Vector stores search them. On the Ollama library page, you can see model sizes and which task each model fits. We will use Llama 3.2 for answers and Nomic embed text for search vectors. Open the project in VS Code. In the Explorer, you should see data, SRIC, and requirements.txt. Start with requirements.txt. Each row is one Python package the bot needs. The core package is LangChain. It gives you chains, prompt templates, and the runnable API. LangChain community adds integrations like document loaders and third-party connectors. LangChain Ollama is the bridge to your local Ollama server for chat and embeddings. LangChain Chroma wraps the Chroma vector store for retrieval. ChromaDB is the embedded database engine that actually stores vectors on disk. Now open build index.py inside SAC. You run this script once to ingest policy files. Start with pathlib. Path gives you folder locations that work on both Windows and Linux. Import Chroma from LangChain Chroma. This is the vector store we persist to disk. Directory loader scans a folder. Text loader reads each plain text file into a document. Ollama embedding sends text to your local Ollama server and returns a search vector. Recursive character text splitter breaks long policies into smaller retrieval-friendly chunks. Data dir points at the data folder. We keep warranty and safety files there. PRSAT is where Chroma saves the index, a ChromaDB folder beside data. Define main. Everything below runs inside this function when we build the index. Create a directory loader. This object knows how to find and read your txt files. Parser of data dir. The loader expects a string path, not a path object. Set glob to ***/*.txt so every text file under data is included. Loader closes text loader that tells directory loader how to open each matched file. Loader quag sets encoding to UTF-8 so special characters in policies load correctly. Close the directory loader call. The loader is fully configured. Call loader.load. That returns a Python list of document objects with page content. Print how many documents loaded. You should see one entry per source file. Create recursive character text splitter. Long pages must be split before embedding. Chunk size 500 keeps each piece small enough to retrieve precisely. Chunk overlap 80 shares a little text between neighbors so sentences are not cut awkwardly. Close the splitter configuration. Split documents takes the loaded docs and returns many smaller document chunks. Print the chunk count. Expect more chunks than original files. Ollama embeddings with modelnomic embed text turns each chunk into a numeric vector. Chroma dot from documents builds the store and embeds every chunk in one call. Documents equals chunks, the list we just split. Embedding equals embeddings wires in the Ollama embed function. Persist directory tells Chroma where on disk to write the index folder. Close from documents. After this line, ChromaDB exists on your machine. Print the save path so you can confirm the folder was created. The if.name equals the main.guard runs main only when you execute this file directly. Call main open parent close parent to run load, split, embed and store. Open ask support.py. Support staff run this file when a ticket question comes in. Same pathlib import as before. We reuse path to locate the shared ChromaDB folder. Create retrieval chain is the high-level helper that retrieves context before the LM answers. Create stuff documents, chain packs, retrieved chunks into the prompt for the model. Import Chroma again to open the index that build index wrote. Chat prompt template keeps the system and human messages structured and reusable. Ollama talks to your local chat model. Ollama embeddings embeds the user question for search. Pierce stdr must match build index exactly so both scripts share one database. Build prmpt with from messages. 2 messages, a system rule and a human template. The system message tells the model answer only from context and admit when unsure. The human template has context and input placeholders. Context is retrieved text. Input is the ticket. Close the message list. The prompt template is ready. Define main for the support bot. This function wires retrieval and generation together. Inside main, create the same Ollama embeddings client for query vectors. Open Chroma with persist directory and embedding function to attach to the saved index. Persist directory points at the folder build index created. Embedding function tells Chroma how to embed new questions at query time. Close the Chroma constructor. The vector store is ready for search. As retriever with k equals 3 returns the top 3 matching chunks for a question. Ollama with llama 3.2 and temperature 0 favors factual support answers. Doc chain connects the LM to PRO empty so retrieve text fills the context slot. Chain combines retriever and doc chain into one invoke call. Set question to a realistic Northline ticket about hydraulic pump warranty. Chain.invoke with input question runs, retrieve then generate. Print the question so the log shows exactly what was asked. Print result answer. The grounded reply pulled from your policy files. Same.main.guard so importing this module does not auto run the bot. Call main to execute the sample ticket against your local index. Open PowerShell in the project root and confirm Ollama is installed. Pull llama 3.2 once. This is the chat model for answers. Pull nomic embed text once. This model creates search vectors. Install dependencies with pip install -r requirements.txt. Run python /build index.py and watch for loaded and split in the output. You should now see a ChromaDB folder beside your data directory. Run python /ask support.py to retrieve chunks and generate an answer. Read the printed answer. It should quote warranty language from your local files. A good answer names the 12-month hydraulic pump warranty straight from the policy file. If the question is outside your documents, the bot should say it does not know, not invent facts. That is why retrieval comes before generation in a corporate support bot. Support staff get speed without pasting confidential PDFs into a public website. Local models need RAM and disk. Smaller models answer faster but no less general knowledge. RAG reduces hallucination but does not eliminate it. Human review still matters for legal text. Tune chunk size and overlap with real employee questions to improve retrieval quality. Cloud APIs may still make sense for public marketing copy that is not confidential. Your private GPT wins when data sensitivity and audit trails matter more than the largest model. You loaded Northline documents, embedded them with Ollama, and chained retrieval in LangChain. The air gap stayed closed. Policies never left your machine on the way to an answer. When legal asks for a compliant assistant, remember the skeleton index locally, retrieve, then generate.